Today we're going to look at adding and subtracting rational functions. Yesterday we looked at just simplifying these functions, which we will continue doing today, but now we're going to add in how do we add and subtract if we have multiple of these together. Well, the best way to start this is just to look, let's remember, okay, how do we just add and subtract two fractions? So if we start off with the equation or the expression 1/2 plus 2/3, what you're going to remember, hopefully, is that to make this work, what we have to do is we have to create a common denominator. So if we look at, okay, what's the common denominator between 2 and 3? That was going to be 6. So the least common multiple, right? So we're trying to figure out, how do I turn in these two into something that will now be over 6, right? Plus something over 6. Well, to turn 2 into a 6, we were going to multiply by 3, and we have to multiply by 3 over 3 because we need, that is 1, and so we're really not changing the problem if we multiply something by 1. Okay, and then in this case, in the second term, we'd look like, okay, what 3 multiplied by what will equal 6? Well, that in that case, it's going to be 2. So we multiply 2 over 2. So in the first term, we have 1 times 3 is 3, and 2 times 3 is 6. So that's good. And the next one, we have 2 times 2, which is 4, and 3 times 2, which is 6. And now at this point, we have enough information to add these things together. So we can do, 3 plus 4, and the denominator stays the same. So then it would be 7 over 6. And if we could simplify, we would, but in this case, we don't have the opportunity, so it's just 7 over 6. Now, let's look at one that just gets a little bit more challenging. And so in this case, if we have 5, 6, plus 4 9ths, it can be a little bit harder to figure out what the common denominator might be here. So what I would do, and what I would suggest you doing, is first, let's factor the denominators. So 6 can turn into 2 times 3. And 9 can turn into 4 over 3 times 3, because 9 can break down, those are the factors of 9. So if we look at what we're talking about, we're going to have 9 over 2 times 3 times something new to create that common denominator, plus 4 times 3. So now we're going to have something that looks like that. So we're setting this problem up. Well, let's look at what's common between these. So there's already a 3 in both of these. So I'm highlighting what's common in between the two. Now what's not common, so in this case the 2, the other term needs. So this term is going to get 2 over 2. And then in the same way, right, this term, the first term needs an extra 3, so it's going to get a 3 over 3. So now when I multiply these together, we will get 15 over, and this is where right now I'm actually going to leave this factored, 2 times 3 times 3, plus 8 over 2 times 3 times 3. Now when we add them together, we're going to get 23 over 2 times 3 times 3, which in this case 23 is actually a prime number, so we're going to not be able to factor that, and 2 times 3 times 3 would be 18. And so there would be our answer, because we weren't able to simplify. But what you see is, right, factor the denominator, and then the way I think of it, what one denominator doesn't have, if the other one has it, that's what we have to multiply by. So we're going to use that idea and come into, okay, how do I do that when I have two rational expressions, or a rational expression? Okay. So if we look at this one, first step, the first thing I always like to do is factor any denominators that we have that can be factored. So in this case, 2, we would have x plus 2 over x minus 2, or 2 over that. The second term has nothing to factor in the denominator, so we're just going to leave it. Again, I'm going to add parentheses around any factor just so I know that it's kind of stuck together. So now if we look at this, each denominator has an x plus 2. And the first term has an x minus 2 that the second term does not have. So we're going to have to multiply that second term by x minus 2. The first term has everything that the second term had. So this first term doesn't need to be multiplied by anything. So now, when we have this, it'll be x plus 2, x minus 2 in the first one. Plus, when we distribute this, it's now 3x minus 6 over x plus 2, x minus 2. And you do need to expand the top, because when we add together, now we're going to have to add like terms. So the 3x would stay, but it would be 2 plus negative 6 is negative 4. And I would still have x plus 2, x minus 2. Now in this case, we can't simplify this anymore because 3x minus 4 is fully factored, but I can add the same restrictions that we had talked about yesterday. Any x value that would make the denominator equal to 0 needs to be listed there as an x is not equal. So if you're looking for kind of the steps, okay, how do I do this, right? The first step, factor denominator. Right, 2, we want to find the common denominator. And then 3, we want to multiply to create common denominator. Once we do that, step 4, we expand numerator. Step 5, we add numerators, add/subtract. And then in step 6, factor numerator. In step 7, simplify. I know it kind of comes off as a lot of steps, but once you kind of get in the groove of it, it will get a little bit better. So if you want to follow those steps and try the one listed below, pause the video, go for that, and you can start the video when you think you've got an answer, when you get stuck and need a little more guidance. So if you look at this next problem, the only thing that's changed here is now this is a subtraction problem. So again, factor the denominators that we have. So it would be 3x minus 5 minus 2x plus 2. And this here becomes x minus 5, x plus 1. So if we look at, okay, what's the common denominator going to be? Well, there's an x minus 5 in both of these. So when we look at this, and we're going to remain with our x over 3x minus 5. But what I have to add to this first one is this x, or multiply by x plus 1. Right, so we have x plus 1. Then we will subtract, well, the numerator is going to stay the same. I have the x minus 5. I have x plus 1. But what I am missing from this first one is the 3. Right? You can see the 3 from up there. So we're going to multiply both of these by 3 over 3. So now when I do this, I get x squared plus x over, and I'm not going to expand the denominator because that's just going to create work for me to undo the same thing I just did. Now, for the other numerator, in the numerators, we do have to create that over 3x minus 5, x plus 1. And what you should see at this point, the denominators should be matching. So here, we're going to subtract the numerators, so x squared, x minus 6x is negative 5x, and 0 minus positive 6 is negative 6, over, and the denominators just stay the same. Now, I can factor what is in the numerator, so this becomes x minus 6 over x plus 1. 3x minus 5, x plus 1. And now at this point, you should be seeing this just now looks like a simplifying problem that we worked on the other day. So we should list the exclusions. X will not equal -1, and x cannot equal +5. Then we simplify. You see that there's an x plus 1 in both the numerator and denominator. So then we can divide those out to become 1 and write down what is remaining. And now that is the simplest version of our expression.